it is part 3 of section 8.A, tests for convergence and divergence. When we cannot evaluate an improper integral, we may try to determine whether it converges or not. If the integral diverges, then that's the end of the story. However, if it converges, then we can use numerical method to estimate its value. Here the principal tests for convergence or divergence are the direct comparison test and the limit comparison test. We'll begin with the direct comparison test. Here, two functions are continuous over the infinite interval, and now g is larger than or equal to f for all x larger than or equal to a. Then, once integral of g converges, then integral of f must be convergent. The reason is that the larger one, for the larger one, the value exists, then for smaller one, it must be convergent. Now, once integral of f diverges, then now for bigger one, integral of g should diverge. It's quite straightforward test. Let's see these examples. Okay, here, now the integrand is sine squared x over x squared. But this integrand is bounded by 1 over x squared. We know that integral of this 1 over x squared is converges, so that integral of this given function should converge from the direct comparison test. In 1 over x to the p, p is larger than 1, then it is convergent. We know that. Okay, for this integrand, we can find here 1 over x is, now that is because 0.1 is subtracted, so that this one is larger than equal to 1 over x. But we know integral of 1 over x diverges, so that the given integral should diverge. Right? Okay, here for this integrand, it's not easy to get the exact value. However, between 0 and pi over 2, it is bounded by, and also is larger than equal to 0, and bounded by 1 over square root of x. Cosine x is always bounded by 1. Now, for this term, here, at 0, it has infinity value, so it is an improper integral. So here, we try to get integral from a to pi over 2, and we take a limit, a approaches 0 from the right side. Then here now, antiderivative of that one is given here, and we are evaluating from a to pi over 2. So we reach at this term. Now take the limit, then we have a final value square root of 2 pi. So it is convergent. For this larger one, the integral is convergent, so that for smaller one, the integral should converge. Okay. Now we'll go limit comparison test. Okay, f and g are positive and continuous over this infinite interval, and if the limit of f over g is L, so L is not 0, not infinity. Some finite value is non-zero, and positive non-zero value. Okay, then integral of f and integral of g behave the same. That means that once one of them converges, then the other one converges. And one of them diverges, then so does the other one. So both converge or both diverge. Okay, let's see this example. For this one, show that the integral converges by comparison with this one. Okay, let's try to use this limit comparison test. Okay, we call this integrand f, and for this one we call it g. Then for part A, f over g, that is same as, now top is 1 over 1 plus x squared, and bottom is here 1 over x squared. So that is same as x squared over 1 plus x squared, right? Now, if we take limit x approaches infinity, then now we know that that is approaching to 1. It is positive and a bounded number, so that the integral of f and integral of g both converge or both diverge. However, we know that this is convergent, so that here the given integral should converge. Okay, now part B, find and compare the two integral values. Okay, now for the first one, from 1 to infinity, and f over x dx, which fx is 1 over x squared. Okay, for that one. Now, antiderivative is arctangent of x, and from 0 to infinity. Now, because it's improper integral, and you have considered here up to a certain point b, and you have to take a limit, b approaches infinity. But if I write down in this way, then you have to understand this one in this way, rather than here infinity, that is practically b, and you are taking here now limit, and here b approaches infinity. Okay? Okay, in this sense, you have to understand that anyway, here when x is infinity, then arctangent, the value is pi over 2. And then for 0 is 0. Right? So that the final answer is pi over 2. Okay, secondly, from 1 to infinity, and g over x dx. Okay, that is 1 over x squared. The antiderivative is minus 1 over x, and we are evaluating from 1 to infinity, which is same as 1 minus 1 over infinity, so that is 1. Okay, so here the ratio in this limit comparison test, the ratio, limit of the ratio, is not saying that the relationship between two values. However, it is saying that one is convergent, then the other one should converge, and one is divergent, then the other one should also diverge. But this ratio is not 1, so that it doesn't say that the ratio between the value, integral values. Okay. Okay. Investigate the convergence of this integral. Now, okay, that is, and if we possibly, because now here that term is converging to 0, so that we may try to compare this whole thing for f here, and along with the g is 1 over x. Okay, so let's try to take the ratio. Then that is 1 minus e to the minus x here over x divided by 1 over x. Right? Okay, then this term is same as 1 minus e to the minus x. Now, if we take a limit and x approaches infinity, then it is converging to 1. So that here the behavior of convergence is the same, but we know that integral of g 1 over x is divergent, so that this integral must be divergent. Okay. Okay, for this one, now, okay, as x goes to infinity, then this 1 is relatively small, so that the behavior of this f as x approaches infinity is more or less around here square root of x over x squared. So that is same as now here, okay, 1 over x 3 over 2, right? Okay. Now, also integral of that g is exists. We already know that 1 over x to the p is larger than 1, then the integral converges. We already know that. So now by using the comparison, okay, limit comparison, okay, we can test that the convergence of this one. F of g, that is now a square root of okay, x plus 1 over x squared. And the bottom is now, okay, we may write down that term. So that is square root of x and x squared. If we multiply bottom and top x squared, then that becomes square root of x plus 1 over square root of x. Once x approaches infinity, then it is approaching 1, right? So it is 1. So limit is 1 as positive number, so that, but we already know that integral of g is convergent, so that this one, this given integral should converge, right? Okay. You may try to get exact value. However, you may get also estimation by using a numerical technique. Okay. Okay. That's the end of the section. Thank you.